My name is Mikhail Savushkin, and in Kaspersky, I handle transport security, in particular automobile manufacturing. Since 2017, we've gone through a lot. And to start, I want to talk about what a modern car is. Right now, the auto industry, like many others, is experiencing huge changes. Most of this is due to digitalization, changing the business model, as mentioned earlier, for example, with subscriptions. But all this is often based on smart electronic units located inside vehicles. The first electronic units appeared around the middle in the late 50s, engine control units, and every year their number kept growing and growing. Now, regular car manufacturers use about 100 to 200 electronic units, smart electronic blocks per vehicle. There's a slight difference in new car manufacturers like Tesla, Rivian, and other electric car manufacturers. They're trying to minimize the number of smart electronic units, increasing their productivity, cutting as much as possible. For example, this week, one of Rivian's top executives said that they reduced the number of electronic blocks from 100 to 17. This is huge progress. Why is it so important? As an example of car architecture, here's a simplified diagram. This is a diagram from a project using our solutions based on KasperskyOS, KASG, Kaspersky Automotive Secure Gateway. Here you can see that there are several high-performance blocks. This is an ADAS unit, this is an autopilot unit, pilot, central gateway, multimedia, and they're all connected, a huge number of different interfaces, networks, etc. So huge thing is no longer a computer on wheels, it's a network on wheels. If we look at what the car looks like from the point of view of production, the supply chain, we'll see that the car manufacturer is responsible for the car itself. The car manufacturer is made up of subsystems that are provided by first-tier suppliers, or the car manufacturer itself can make them. They assemble the car, and these subsystems made accordingly from other elements, smart blocks they're supplied with, as there are already large suppliers. But at the same time, these smart blocks consist of a large number of subcomponents, chips, software, and more. These are second-tier suppliers and onwards. So the car manufacturer may not have anything to do with the development of devices or software. Moreover, sometimes even the car manufacturer doesn't have their own factories to assemble certain models. Such a large number of components is well illustrated in an interview with the head of Ford, where he said when they released the new Ford F-150 electric vehicle, he stated that they have more than 150 smart devices in the car, and the development process is done in such a way that these manufacturers don't communicate with each other. They don't understand what the others are doing. For example, the sensor manufacturer doesn't know what the multimedia systems manufacturer is doing. But the scariest thing in this interview for me personally is when he says that they don't understand themselves what the car is made of. They don't have a clue. A large number of smart electronic units attracted a large number of researchers with good and bad intentions. One of the key studies is from Chris Valasek and Charlie Miller. They were able to connect to a Jeep's multimedia and get remote access to drive the car into a ditch. They showed that a remote attack is possible. They can change the vehicle's operation. This is a huge deal. Following this, 1.5 million vehicles were recalled. At the moment, there were no mechanisms for full mitigation of these vulnerabilities, and they spent a crazy amount of money. Then the research really started flowing. Here I'd like to highlight several studies Kaspersky lab had some good ones in 2019 to 2020. These studies were recognized by BMW. Our team who conducted this research are in the BMW Hall of Fame. The team who presented earlier today conducted Telit research for the Telit company research, which is also used in the automotive industry. They're a serious researcher. Also, last year, Mozilla released some good research about what data cars collect and who they pass it on to. It turned out that almost all the data about anything you can do in a car goes to a third party. Naturally, government bodies, national bodies, supranational bodies aren't on the sidelines either. In 2017, on the basis of the United Nations defending the development of an automotive cybersecurity standard, in 2022, it's already been applied in Europe, Japan, Korea, and national standards are appearing this year in China, India. So in the end, no one will be uncovered. If we look at the number of incidents related to automotive data, we see that most attacks affect smart blocks and external connections. But in these reports, the most interesting thing for me is that the largest number of officially registered vulnerabilities are vulnerabilities related to suppliers of the second level. So major automakers can somehow control things, large suppliers can handle some control, but no one looks at what's inside, what is the automotive cybersecurity standard. There's an international organization that deals with the standardization of machine certification verification. There's a standard that requires the creation of an information security system for means of transport. This information security system, information system management, must cover the entire life cycle of the vehicle from the design stage to production, operation, and disposal. On every stage of the car's life, there should be solutions, methods, monitoring, and so on. And this data is submitted simultaneously with the certification of the car to the regulatory body. So we do crash tests, and at the same time, the car manufacturer submits a certificate that we have cybersecurity, we handle it, everything is fine. An interesting thing about the auto industry is that the certificate is temporary. It must be confirmed once every 3 years. So after 3 years, the company again needs to conduct an audit to ensure that everything works. But also the regulator demands that the car manufacturer provides confirmation that its suppliers also use the system of information security management in their own development of solutions. So car manufacturers are required to ensure that security is ensured throughout the entire life cycle of vehicles throughout the supply chain. This is already implemented for all cars in Europe coming off the assembly line. And missing certification leads to suspension of vehicle certification, which means the end of the vehicle's life. I tried to highlight a few points from our experience, from our projects. The first point I think is relevant to everyone. This is that information security should be managed for the organization in a centralized way that also takes into account suppliers. So information security must cover developers, production, dealers, everyone. It should be centralized. Also, it should be carried out during the development of the car. When building systems, cyber resilience should be implemented. For example, cyber immune solutions. The system must be resilient to the fact that it will try to be hacked. That's a fact. The system must also be resistant in terms of physical security. These blocks must be designed taking into account that they'll be hacked. Unfortunately, this is the reality. Also, another interesting thing about the auto industry that we rarely see elsewhere is building development processes taking into account the mission. The system must work even in case of failure. For example, if a car is hacked, it would be great if the brakes still worked or the steering wheel turns. That would be great. That's how cars are developed. So it seems to me that it would be great to develop systems in factories. Another important thing is the process of renewal. The update process in the auto industry is expensive. If there are no remote control update systems, then you have to go to the service center where they do something to you manually. This is very expensive. We need to understand very clearly what we update, why, and for what reason. And this information, the answers to these questions are built on testing, receiving data, for example, threat intelligence, modeling whether what we're really doing, what we want to do. Will the changes be helpful? One more thing is the requirements for suppliers. Today we heard in the previous presentation that suppliers in principle must fulfill the requirements they want to see from everyone. A safe development process must be organized. It must be clearly stated to suppliers that there can be pen tests. In some countries, it's simply prohibited. You can go to jail for this. Also because there are no mechanisms for providing technical information to the manufacturer, so we have to work outside contextual requirements. On a general level, formulate requirements for subsystems and for equipment, and based on this form, the product. One more thing from me. The auto industry is now trying very hard to eliminate cyber risks. But most cars we see on the street at the entrance to the hotel here, they were developed long ago, before cybersecurity became a big deal. Moreover, there are no cybersecurity requirements in some countries where these cars came from. There's no way to verify the cybersecurity tools implemented in these cars. We don't know certain things. There's often no option to fix vulnerabilities, even those discovered under current conditions. In Russia, we can't say that a vulnerability we discover will definitely be eliminated.